Good afternoon. Let's take a look at volume of revolution around the y-axis. Already previously we have looked at volume of revolution around the x-axis, so now we are going to take a look at volume of revolution around the y-axis. The following is an exam style question. Let's read. A drinking glass is modeled by rotating the graph of y is equal to e to the x about the y-axis. For y is larger than or equal to 1, less than or equal to 5, find the volume of the glass. So we know that for volume of revolution around the y-axis, we have the following equation. The volume is equal to the integral with my lower bound and my upper bound of pi multiplied with x squared dy. This is when I want to find the volume of the curve around the y-axis. So I'm going to integrate in terms of y. Now we notice that we are given y is equal to e to the x. So the first thing I want to do is I want to rewrite this in terms of x so that I can substitute something here in terms of x. So if I want to make x the subject, we see that it is base e, so therefore natural log y is equal to x. So I can rewrite my volume, and now of course pi is a constant, so pi can be outside with my integral. We know that y is larger than or equal to 1, less than or equal to 5, so they have given us our lower and upper bounds. In terms of x, I can now substitute in natural log y squared, and I am going to integrate this in terms of dy. Now, previously when we have done integration, we would have noticed that the moment I want to integrate a natural log, I cannot do it by substitution. I will have to do integration by parts. That is the easiest method alternatively. So I'm going to say the integral of pi, and now, the volume is equal to pi, integral of my lower and upper bound. Now I'm going to say natural log y squared multiplied with 1 dy. Now this is going to help me to set up my integration by parts. So I'm going to say u is equal to, and now my bracket, natural log y squared, and I'm going to say dv dy is equal to 1. Now I'm going to differentiate u, so I'm going to have du dy, and the moment I differentiate this, I'm going to say the power times to the front multiplied with the derivative of the inside. The derivative of natural log y is 1 over y, and then just from my chain rule I'm going to be left with natural log y. dv dy on the other hand, I am going to integrate. So if I integrate dv dy, then I'm going to say v is equal to y, because I'm integrating in terms of y. Now if I want to set up my integration by parts, I'm going to say this is equal to pi, and I'm going to have a nice big bracket here, and now I'm going to say my inner bracket is always u times v. So in this case it is y multiplied with ln y squared, close my internal bracket. Remember we were integrating with my upper and lower bound, minus the integral of, and now okay, let's go and write it out then. So the integral, I still have my upper and lower bounds of du dy times v. So I have 1 over y natural log y multiplied with v, which is y, and I'm going to integrate this whole thing in terms of dy, and there should be a nice end to my big bracket here. So now I am going to say, okay, pi, and I'm going to, at the moment, I'm going to leave this thing here. If I wanted to, I could have already integrated this with my bounds, but let's for the moment first leave this here. Natural log y squared, close my bracket, 5, 1, minus. Now 2 is a constant, so the 2 can go outside. Now I see here I have 1 over y multiplied with y, which gives me 1. So I am left with the integral, lower and upper bound of 1 and 5, natural log y dy, and I close my bracket. Okay, so I'm going to continue here on this page. So Of course, we can see here, I have just rewritten what was here at the end of the page. So remember, this pi is on the outside of my big bracket. So by integration by parts, I had my first integral here, my definite integral with 5 and 1, minus, and then I had my integral of, in this case here it was du over dy multiplied with v, which simplified to the integral of natural log of y. Now, unlikely for us, we notice that we have another integral in terms of natural log of y. Therefore, I will have to use integration by parts again. So in this case here, I'm going to set again u is equal to natural log y, and dv dy is equal to 1. So I'm going to differentiate this. Du dy is equal to 1 over y, and if I've differentiated u, and I'm going to get the integral on this side here, so v is equal to y. Now let's go and set it up. So this integration by parts is for this integral here. The rest I will keep the same. So I'm going to say, okay, sure, I still have pi outside my big brackets, and now my inner bracket y multiplied with natural log y squared, and I still have my upper and lower bounds 5 and 1 minus 2. This 2 was outside of the integral, and now u times v. U times v in this case is going to be y multiplied with natural log of y, upper and lower bound 5 and 1, minus, but remember there's already a negative in front of this, so instead of saying minus here, negative times a negative is going to give me plus, and the integral, upper bound and lower bound and upper bound, of du dy times v. So if I have 1 over y times y, I just have 1 dy. So I'm going to integrate 1 in terms of dy, which I know is just y. So this will give me pi, big bracket, and I can just go and rewrite all of this. I know it's tedious, but we're going to rewrite this, minus 2 y times natural log y 5 1, and now here, so this 2 should have times here in front, sorry, my mistake, there should be a 2 here. So now 2 multiplied with, and now the integral here of y and 5 and 1, and I close my big brackets, and now I can go and I can evaluate all of these definite integrals. So pi on my outside. Now let's go and substitute in 5 here. So it will be y replaced with a 5. 5 multiplied with natural log of 5. 5 ln 5 squared. And now the moment I substitute in a 1 in terms of y here, so natural log of 1 I know is 0. So 0 multiplied with anything is 0. So this 1 here, if I sub it in, will just be 0. Minus, now if I substitute a 5 in for y, negative 2 times 5 will give me minus 10, natural log of 5, and the same here. I have a natural log of y. If I replace y with a 1, I will have natural log of 1, which is 0. So 0 multiplied with anything will be 0, so I do not have to write that. And now, plus 2 times 5 minus 1, which is 4, times 2 will give me 8. So now I can go and expand this, and I am going to get, so of course I can just go and write it like this, pi, or 5 pi, times natural log of 5 squared, minus 10 pi, natural log 5, plus 5 minus 1 is 4, 4 times 2 is 8, 8 pi. And now I have evaluated this integral, and I can say that this is the volume of revolution around the y-axis for this, in this case it was a glass, for this solid that we have found.